Hey, what's happening, guys? Got a bunch of ICs just sitting here, and a lot of them are op amps. There's a 357N, the TL072. There's an LF353N. I just can't see them anymore. My eyes are too bad. Anyway, probably one of the most useful ICs in the world is an op amp. You're going to find them just about everywhere. But there is an issue with them, and that is they mostly require a dual voltage source, meaning a positive 5 volts or 10 volts and a negative 5 volts and 10 volts. So, and the reason for that is so that the op amp can swing. Let me show you what I mean by that. If we have think of this like a virtual oscilloscope. And right here, we'll call this 0 volts. This is 5 volts. And this is minus 5 volts. So if we are powering the op amp, like a 741 for instance, with positive 5 volts and a negative 5 volts, then that op amp is going to be able to swing the signal almost. That's a brand new pen. Almost to the extremes. It can't go to the extreme because it's not a rail-to-rail op amp. So this is what's known as headroom. And there is going to be a little bit of this headroom where the op amp can't get to. But if we power it with, say, a virtual ground circuit, and I've done a video on that, it's really easy to do. Now, if this is 0 volts, and say we're powering it with 10 volts and 0 volts using a virtual ground, well then our center point becomes here at about 5 volts, and then we can only swing the op amp in this range. We can't have any of the negative range, which in some applications is fine, but in other applications it creates a problem, especially in audio applications where you need both positive and negative voltage sources. So what we're going to do today is we are going to create a circuit that you can use with your op amps. And to do that, we're going to use this chip right here, the ICL7660. Wrong way, Paul. So the 7660 is a CMOS switched capacitor voltage converter, and what it allows, one of the things it will allow us to do is create a negative 5 volt supply from a 5 volt supply. And you can see the negative voltage converter will work like this: cap positive, cap negative, ground, and we'll have a negative output voltage with a positive input voltage. So this is going to be really cool. And let's just take a look at some of the specs here before we move on. 1.5 to 10 volt operating supply voltage. So good, we can power it up to 10 volts, which is perfect for op amps. 98% efficiency. Awesome. Boost, we're not using that. No load supply current, 200 microamps. That's not bad at all. You can pause and zoom in on that if you're interested in reading about the specs of the chip, but I want to get down to the nitty-gritty. There's a test circuit. One more page and we should be there. Yes. Basic negative voltage converter. So that is what we are going to build. And we're going to build it on a PCB from PCBWay, who is sponsoring this video. So let's take a look at it. It's an 8-pin chip. We'll be connecting a 10 microfarad capacitor between pins 2 and 4. Pin 3 will go to ground. Pin 6 will go to ground. perhaps I'll have to read that. Pin 8 is a bypass cap, and then pin 5 will be our output with another bypass cap on it. So let's head on over to the computer and lay this out. Alright, so we got everything here laid out, the schematic anyway. We'll do the board together. Pin 7, the oscillator, pin 6, the LV are not connected. They're NC'd. Just like the schematic says right here, we're using a 10 microfarad for between the positive and negative cap to generate our negative voltage. And then I'm also just going to use 10 microfarads for these two bypass capacitors here. And then we have a jumper over here, a 3-pin. We'll have out plus, out minus, and ground. And that should be everything that we need. And we should now be able to take this and make it into a PCB. Alright. So here we have all of our particulars. Let's move them around here a little bit. Hey. There is our output. There's a cap. There's a cap. There's a cap. And frankly, I don't like any of them. Alright, so I redrew the components I didn't like. Let's go to edge cuts and draw our board here. Doesn't need to be too big. Alright. So now we can lay out excuse me. Now we can lay out our components. Pretty simple here. We'll do our best to get everything laid out as smoothly as possible. We're just rotating things, trying to see what fits better where. Not too bad. That's not too bad. Heck, even that's not too bad. This here is somewhat an issue. See how we're crossed up there? If we do that, we can almost bring all of our capacitors to one place, which is something I like to do. Just a matter of where. Alright. Not too bad so far. Okay, as you can see, I changed the this connector here. It was making me nuts. Put that over there. And we're going to go to front silk screen. Got to change my spacing. Try this again. That's better. And we'll do it again, so we know which is which. Good. Now we're back to this guy. Thinking maybe we'll go vertical with it. Maybe. Let me play around for a minute and we'll see what I can come up with. Alright, I'm getting pretty happy here. But I would like us all to keep in mind that I am not a professional PC board designer. I do this as a hobby. I can teach you the circuits, but honestly the design of the PCBs is not me. I tend to just like line things up, and that's, you know, probably not the best way to do things. But, you know, like I said, simply do this as a hobby. Alright. So we'll put some silk screen on here. We'll try and spell it correctly. And then we'll need our happy bear, won't we? Before we get the bear, we should route. So, where shall we start? Text? No, we don't want to. If we don't want no stinking text, we want the route. Front cover. Whoops. Oh, how I wish for an auto router. My kingdom for an auto router. Before you do that, oh, because that's where you're going. Okay. That's a 90-degree turn. Not the best option. But just trying to see if I can get as many of these routes on the top as possible. Now we'll go to the bottom. Guessing that needs to go there, huh? That's not going to work. Where are you supposed to go? Ah. Oh, try like this, huh? Hello? Why are you not letting me do this? Alright, little correction, I think we're all better routed now. I hope. God, that was a little crazy. I remember I'm still learning how to use KiCad here. Alright, now for the Happy Bear. If I can just remember where it is. Oh, there she is. Okay, we'll put them on the back copper. Alright, so far, so good. Let's see what happens. Now I could have swore I put the bear on the back. That's alright, I'm fine with the bear on the front. Whoa. Hit the wrong button there, didn't I? Alright, let's add some copper here. We want to go to the front copper. And we want to put it on our ground. Hey. Good, I think. And let's add some copper to the back too. Also to the ground. So we'll have a nice strong ground plane in case we're using any what's the word I'm looking for? High frequency type applications.
Alright, let's take another look at it. And the bear is still on the front. But you know what? That's what we're going with. Bear on the front. Alright, let's order up these boards. From PCB Way. Our size is 48.3. Whoopsies. 48 point. Yes. Thank you. Let's do this again. 48.3 by 25.4. It is 2 layers, FR4. We want 5 pieces. Oh, blackboards today. White silk screen. No gold fingers. Yes, we'll accept that. Looks good. We'll add to the cart. Upload our Gerber file. Submit our order. There it is, $5 plus $17 for that super fast delivery, and we'll have it in just a few days. So hang on to your horsies.
Well, about 5 days have passed, and our boards are back from PCB Way. And they're looking pretty good. If we can get it to focus. There we go. We've got our input here, our output here. Our chip, the ICL7660. Our capacitors. And of course, the Happy Bear. Yep, looking good. What say we put them together? There she is, all nicely assembled and whatnot. Let's put a couple of jumper wires on here. Red for positive and brown for ground. Try and keep them nicely separated. Or as nicely separated as I can manage. Alright, so over here on the old power supply. Yeah, hold on. Whoa, going handheld. You can see we got putting in 9 volts there. Alright. Then we'll put on some more jumpers. Yeah, hell with it, we don't need jumpers. Alright, I got a meter set up here. This is the Zotex ZTM1. And we got some probes. So we will put the black probe on our ground connection, like so, and the red probe on our positive. And you see we're getting about 9.06 volts out. And yeah, I'm going to have to put connectors on there, otherwise I'm going to end up shorting this out, and we don't want that. So alright, we'll go. Come on, fingers. We'll go black for ground, gray for our negative voltage, and white for our positive voltage. So then we'll hook up our ground again, and our positive voltage 9.07, and our negative voltage minus 8.76. Well, it's a little bit short, but it's close enough that it's not going to matter. And there you can see everything all hooked together nice. Remember, nothing is ever perfect due to tolerances in manufacturing. It's only perfect in theory. But there it is. Our dual voltage power supply board. A really easy circuit. Come on, focus. There we go. Now, I think for our next project, we will take this and pair it up with an op amp, maybe a TL072 or an 082, and we will put together a basic audio amplifier. What do you guys say to that? Alright, that's about it for this video. It's long enough. If you enjoyed it, though, hope you'll give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to all the patrons. That's it. I'm out. Peace.